Cool, welcome back. It is day number 4 of the in-depth Postgres training. And I'm ready to dive in. I've got the happiness hints up on the board. We've actually hit a whole bunch of these happiness hints already. I don't know if you've been paying attention. We've talked about PIEM, PG stat statements. Talked about a couple of the alarming things. Yesterday we talked about temp usage. We've talked about upgrades now and the updates and everything. We've touched on vacuuming and what vacuuming is. Really, actually, we're going to finish these out today. So, and actually along those lines, what I'm going to do is, before we jump into, so today is break fix day. That is our title for the day. And this is my favorite day of the week, by the way, by far. But before I get into that content, we've been going through the happiness hints. There wasn't really anywhere else I saw to fit this one in this week, but I wanted to just real quickly touch on connection poolers. I'm not going to spend a long time on this, but this is a pretty important strategy for Postgres. I think one of the reasons that it's important is that one thing about Postgres is that it's memory management can be a bit of a challenge, and if you need to carefully manage connections. If you start getting into really, really high connection counts and they're long-lived and they're doing things, you can get into situations that gets you into trouble. In fact, there was also huge pages you saw as a happiness hint, and these two things are both related, or they're both related to not running out of memory on your Postgres server. Both of them help quite a bit with that. Up here on connection pools, it says there's really two different models for this. A lot of people have connection pools built into your application already, and that's one approach to take. There is also another approach that people sometimes take of doing a centralized connection pooler, and this is where you're actually putting sort of a connection pool in between your application and the database. You're setting up like a server, and there's some software packages people use. Regardless of what connection pool technology you're using, one thing that I just want to specifically call out on this slide is this max age idea. And even the bullet point here, you see it helps reclaim bloat. So one thing about Postgres that I've noticed is that sort of over the life, and this is the thing with a connection pool, you'll make a connection, Postgres will start up a background process, and that process is going to stay there as long as the connection's alive. And over the lifetime of that process, it might run a query at some point that needs a lot of memory, so it's going to allocate, maybe it's doing a sort, maybe it's just buffering some stuff. And what I have observed is that, so Postgres will try to release some of that memory, but it doesn't always get released back out efficiently and effectively. So over time, what we often see is if you have really long-lived connections, the memory just kind of starts to climb. So that's one of the reasons it's pretty widely considered a best practice to make sure that you age out your connections in your connection pool and just kind of recycle them periodically. And that's what max age will do. And look at that. And huge pages is even specifically mentioned on here. I'd forgotten that was the last bullet. So right there, that covers 2 more of our happiness hints that I said we'd try to touch on this week. Okay, with that out of the way, let's dive into my favorite day of the week, which is break fix day. So this is the day we get to try to break stuff, which I've just always enjoyed doing for some reason. So first of all, I would like everybody to get out your little pirate patches for your eyes. That's what we're going to start with. And we're going to talk about all the things that you really came to class for this week, right? What did you really come here to hear about? All the fun stuff. Corruptions, inconsistencies, failures, all of the great things, right? This is a lot of fun. Is corruption a bad word, maybe? Is that too harsh? Maybe I should soften it up a little bit. But no, you guys have been around software for a while, right? I mean, you know, software has bugs. It happens. When we think about failures in Postgres, I find it helpful to sort of break them down into 3 large categories. And this is actually kind of a terminology that I hear a lot in a lot of different places. When we think about a database in general, I think that there's sort of 3 jobs the database has that are really important, and these are going to be in order. The first job of a database is durability, right? And what durability means is not losing your data. That's job number 1. If you are responsible for the database, and somebody needs to be, you know, whether you're a DBA or not, your job number 1 is making sure that you are protecting the durability of your data. Don't lose your data, right? Job number 1. Number 2 is availability. So number 1 is don't lose the data. All right, so once we've got that, we know we have the data, then the next thing is making sure that you can access it, making sure it's available to your application. And the third thing is performance. And there is kind of a fourth area too, like when you get into when you start thinking from like a security perspective, you'll start thinking about confidentiality. In the CVE or the CVSS scoring system, they actually use the word integrity. I kind of think of that as durability. So there are a couple other categories to look at, but these right here I think are in order the 3 important jobs of a database, and I think that this is a very helpful way to think about categorizing some of the failures that we're going to see. So I'm kind of starting out high level here, but maybe this is helpful just to sort of list out some different kinds of failures and put them underneath those headings. The thing that probably, like when you think of like, you know, corruption, dramatic failures, that probably the first thing that comes to mind is like this, you know, is completely losing everything. And you know, I've got my share of war stories about this too. I remember one of a previous job where I was a DBA, where we had somebody who punched in a command into they had 2 windows open on their desktop and they just ran the command in the wrong window. One was the prod server, the other one was they were setting up a new dev server, and they knocked out the disk headers on all of the disks on this production cluster. And that was not something that was easily recoverable outside of spending about 10 hours pulling stuff off of backup tapes. It's a long outage. That was like, you know, that's like the classic dramatic story of, yeah, I mean, we didn't lose the data in the end, but it was a long outage while we were pulling stuff off of tapes. Well, not tapes technically in that case, but it took a very long time. But there's a lot more types of failures. There's 1 or 2 that I think I would point out because you might not think of these at first as failures. Like, for example, wrong query results underneath the durability category. And the reason for that is that, you know, if you think about what your database is doing, so yes, you want to have the correct data on the disk, right? But what you're constantly doing is your application is like looking at data, processing that data, and then updating that data, right? And if a query makes a mistake, if you run a query that says, you know, update this record and double the salaries, but then if the query actually triples the salaries instead of doubling them, you see now you've introduced a failure into the system. That's really a loss of data. That's really a durability problem. So even things up in like the query processing system can be durability failures as well. Another thing to think about is like sometimes we think about like maintenance windows. You know, we don't really think of those as like big dramatic failures. Like I had a scheduled outage. But like something, for example, on the RDS side that we think about as we think about availability is making sure that maintenance things happen within a reasonable period of time. Like if some maintenance operation is taking like 45 minutes or an hour, you know, even if it was an expected scheduled thing, like the customer, you know, I clicked a button and I started that process, like an upgrade or something, right? But it stretches out and out and out. That becomes an availability event at some point. This is a sad conversation that I personally observed in the Postgres Slack room, public Slack channel. And I've blurred out the names to protect the innocent. And you don't have to read through all of it. But this was a sad conversation with somebody really begging for help because they had made a mistake and lost the data. And they did not have a backup in this case. And if there's sort of one point, I said this a moment ago, I'm going to say it one more time. I think as I introduce my break and fix day, one thing that I am going to do is draw a little bit on my background as a DBA and just try to sort of emphasize some things that, like, if you've been a DBA, this should sound really familiar to you. But it's really important things I find. Increasingly, we're all involved in operations, whether you're a software developer, whether you're a DBA, whether you're a sysadmin. And there's one thing that got drilled into my head over years and years and years of database administration, which is that job number one is don't lose the data. Job number one is don't lose the data. When I went through Oracle certifications, I remember the first thing was backup and recovery. You know how to back up and you know how to recover a database, and that's job. Everything else is after that. You could be the best query tuner in the world, but if you don't keep the data safe, you're not the right person for this job. You have one job, your first job, and I think that this is a good thing. As I start getting into ways to break the database, as we start talking about how different kinds of failure modes and what to do about those, I just want to kind of put this in perspective and set the stage, and remind us that sort of the first job, and this is easy to say now, and I'm emphasizing this now while we're in a class, because when something actually happens to your application, when the real thing happens, it's surprisingly easy to forget this. It's easy to jump ahead and start thinking about all sorts of other things, like finding the bug, for example, or how you're going to what you're going to do next. It's surprising, as opposed to just remembering job number one is just don't lose data, be very careful, take your time, that kind of a thing. Okay, so I promised we'd do some interesting stuff. We'd break some things, and we are going to, but before we break things, I'm going to talk about, safety first, right? Safety first. There's some pretty important safety equipment, and I mentioned the first one just a moment ago. From my experiences, your first safety tool is backups, right? In the world of RDS, backups are based on snapshots, and then we take the wall logs periodically and push them off. We do both. So when it comes to recovery, you can do both the type of recovery where you just take and grab a snapshot and just pull the snapshot. And then there's the second kind of recovery where you do a roll forward, where you apply wall logs and actually roll to a point in time. So you can say, just give me the snapshot that was taken last night during the backup window. Or you can say, recover the database to 1:51 p.m. today in 13 seconds. And what will happen is it will start with the snapshot and replay all of the change records until exactly that point in time and stop there. It's really important that you have a solid understanding of these safety tools before you get into a situation where you're dealing with a problem. And I'll get into some of the reasons, because this stuff becomes very tactical when you think about how you're going to move forward with solving problems. So yeah, the first thing is backups. The second thing is going to be multi-AZ, and we talk about MAZ a lot. This is sort of a pretty well-established, well-architected principle. People at AWS are always saying this all across the org. You should always design across AZs, architect your applications across AZs. And this is an important tool. And from an architecture perspective, so I mentioned backups. When it comes to MAZ, probably most of us are familiar with this, but we'll just kind of make sure in case anybody. In MAZ, what happens is you have in your primary AZ, you have a database and you have your storage, your EBS storage. And then in another AZ, you have another EC2 instance, and it has its own EBS storage. And then what happens is this database just accesses the storage, and then there's storage level replication that happens. Okay? So that means that the database doesn't even really know that it's being replicated. The database is just doing I/O to a block device. But when the database does a block write, the storage layer is going to take that block, ship it over to the other AZ, and it won't acknowledge the write until both EBS volumes have the write down on disk. That's going to become increasingly important as we go on later, right? So that's how multi-AZ works. The second really important point to know, so there's two important things that you need to have really solid. These are fundamentals. This is just like knowing how to take a backup and do a recovery. All right, fundamentals. A is understand MAS means storage replication. B is understand that backups come from the secondary. That's very, you need to know where the backups are coming from. Because, again, you'll see this is all going to become very tactical when we start seeing problems. So remember that. Always remember that. When you're doing a MAS, and if you're in RDS, you have a MAS setup, and you start taking, that's it. If you're in RDS, you have MAS, then your backups will come off of your secondary, not off of your primary. Okay? If you trigger a failover, move your primary over there, the backups will begin to come from this side instead of the other side. Okay? So at the next backup window, the next snapshot's going to come from here. The next tool in our tool belt is going to be replicas. This is important because this is, the important point here is that this is going to be different. This is not block level replication. With RDS Postgres, this is a wall-based physical replication. So in the picture here you see I have my MAS cluster on the left with my primary and secondary, and then I have two read replicas. So whereas with MAS we're doing block level replication, this is different. With read replicas, it is the wall records are being shipped over, and that read replica is a physical replica, meaning it's bit for bit going to look pretty close, nearly identical. But it's wall records, and the database is very aware that this replica is happening. Okay. And there's one last tool that's in our tool belt. And the last tool that we have in our tool belt is these logical exports. And by the way, if you didn't notice, we just finished hitting all the bullet points on the happiness hints. These were the last three, right? So logical exports are generally done with a tool called pgdump. pgdump is in your lab environment, so this is something you can fiddle around with if you're not familiar with it, and I would encourage you to do that. There's also there's a pgdump all that you can look at as well. Pgdump all is sort of an easier way to get the entire database out. There's multiple levels that we can operate at here. So this is what you're going to use. I didn't make a slide for this, but there's one other thing worth mentioning, which is logical replication as well. But we'll get into replication stuff tomorrow. If you ever get to the point where you're dealing with a problem, you want to know every copy of your data, where it is, and how it comes about, right? So that's why I'm starting by cataloging all of these things. And in particular, the logical exports and the multi-AZ are things that we consider just sort of standard operating procedure. If it's a production database, you should be MAS. And if it's a production database, you really should be periodically take a logical. You don't want to just rely on a single technology for backups. This is sort of an age-old philosophy kind of a thing. It's good to have sort of a backup for your backup, so to speak. So you just don't rely on one technology. Have two. So it would be okay, by the way, if you have, I would be okay if you have like logical replication or DMS or something like that. I mean, that also works as a second choice instead of logical exports. Although there's some differences there because logical exports, you grab a copy every day or every week and then you keep that for a while. Whereas with logical replication, you've only got the data as of right now. So again, like we're back to like if, it's still a good practice though. So the main point and the main takeaway is two things. Don't just rely on one technology to save your life when you need it. Have two. All right. With all of that said, I now want to jump into a deck. I'm going to actually switch decks here to a different one to talk about a little bit about database corruptions. And this is going to be specific to, we're going to talk about sort of generic Postgres. and some different corruptions in generic Postgres. So let's see here. Bring that over and down. And where is the button I want? Here. There we go. All right, database corruptions in Postgres. Fun stuff. This is where the fun really starts, right? Whoops. All right. What kind of things can be corrupted in the database? Pretty much anything, right? Anything you've got in the database. And so we've listed a couple things out here. So I mean, tables and indexes are easy enough. We haven't talked a lot about, well, so the transaction log, that's the wall, the write-ahead log is what that's talking about. That was the old name for it. We haven't talked a lot about the commit log. I think we've mentioned it this week in class, but we haven't gone in depth yet. We haven't, I don't think, talked about what toast is at all this week. The catalog as well. It really, anywhere in your database, and I would say that over the past couple of years working with RDS, I've seen almost all of these at some point in time. Like it does happen. It does happen. So how do you know when you have a corruption? What does it look like? Well, here's a couple examples of things that you might see. Okay, you might see something like invalid page header in this block. Do we have one? Something else you might see, there's not an example up here, but you might see something that says like invalid checksum. One thing that in RDS Postgres, we don't allow you to turn this off, but Postgres will checksum, put a checksum on every block. And so if even like one little bit gets flipped, it knows that, because when it reads the block in, it's going to check the checksum, and it'll see that it'll see something is wrong with this block, and it'll immediately report an error when that happens. Other things like this timestamp error, the PG xlog, that's old. That now should say PG wall. Starting in version 10, they renamed xlog to wall. The reason for that was because it's a little bit more clear of what it is. Could not access the status of transaction 0. That would be tied to transaction logs. This unexpected chunk size, oh man, I remember seeing that, and that's like an infuriating one. That specifically has to do with the toast tables, when toast tables start getting messed up. So these are the couple of the different things that you might see in Postgres. And when we get to our lab section, hopefully you will see some of these too. I hope everybody has a chance to try some of this out. What do you do when you see a corruption? This is your playbook right here, okay? The first thing that you can do, now this is specifically oriented toward if you're running it and you kind of have full control of it yourself. Now this is Postgres, like in your lab environment, Postgres on an EC2 instance that you're self-managing, you have the ability to you want to kind of stop, pause, right? Sort of take a timeout. So, and this line number 2, take a full backup. One sort of general principle that's always good to keep in mind, really kind of in any crisis situation, is to never delete anything. I've really been surprised how often I've sat down with people doing operations and working through, and it's for me, it's just sort of like automatic. Like when I'm typing, I'll always type move instead of delete, move instead of remove, like just move a file out or rename it. And I'll come back later and clean up. But you know, it's something you always want to kind of keep in mind is don't delete anything. Now, as far as you're able to, if you have a disk space situation where you have to clear out some space on the disk, then what you want to do is, if possible, copy things off before you get rid of them. But the last thing that you want to do is get yourself in a situation where you've made it worse and you can't go backwards. So the next thing, yes, he says here on this slide for the EC2, we say restore from a previous backup if possible. So the first thing that you can look at, is like, can I just use the backup to get back where I was a moment ago and fix it that way? And in the context of RDS, what that's going to mean, and I'll have this on a slide, another slide later that's more RDS specific. In the context of RDS, what that means is the first thing you're going to do is go look at, what snapshots do you have. And in RDS, you start clicking buttons and you just say, let's just do restores, spin up restores of this snapshot, do a point in time restore, and just see if that works. And then at the bottom there, they have diagnose further if a backup is not available. Now, the reason I say see if it works is because, we talked about a lot of different types of corruptions. So there's an awful lot that depends on what kind of corruption you're running into and where it is. And so we've seen things all over the map when it comes to just bugs in Postgres that can cause a corruption just over many years, right? Let me dig into that in a couple of minutes, but let me keep moving through these first. So logical exports are the next sort of level, an important tool. If you're not able to, and I've been in these situations before with Postgres, where if you're not able, if the backup and if the restore is not an option, if you're not able to use the backup to get back up and running and get your data back online, then you might be in a situation where you need to sort of pull as much usable data out of a database as possible and try to work with that. So we're just talking about sort of steps to try to get out of pain right now. So PG dump, you can give that a try. It's an advantage to try to dump the entire database. Sometimes, actually I would say often, if you see an error message, something caused a corruption. So what'll happen is you try to access some particular row, and then you trigger an error message and you access that row, right? Because maybe that row is in a block and the block is messed up. Maybe there's an index that's messed up. But that's quite possibly not the only corruption. Because there had to be a bug somewhere, some unique set of circumstances that's very uncommon or unusual, that somehow a situation came about where that bug was triggered, and if it happened once, it's quite possible that it could have happened more than once. So a big advantage of something like just immediately starting to look. Remember, we've taken a backup. The first thing that you do is you get that backup. In the context of RDS, you can even kick off a snapshot. That would always be the right thing to do in RDS. Like if something is wrong, snapshot now, right? First thing, run a snapshot. That's something you can pass along as well. If somebody's worried, first thing, just tell them, just run a snapshot right now. It keeps you safe. Something to think about is that some corruptions or some problems can be in the wall stream. I've absolutely seen those. I've seen issues where there's like a problem on the disk, and then if I take my snapshot and I replay my redo logs, it replays the problem. Like it actually can recause the same issue. So you can't always even rely on, it just totally depends on what you're running into, on whether the point-in-time recovery. Most of the time, point-in-time recovery works, but maybe you ran into something that's embedded in the wall stream, right? So that's one reason to grab the snapshot, grab the backup. Once we've done that, we can always go back to that snapshot. And that's another thing too, like when you grab a snapshot in RDS, you don't need to do any wall replay to restore that snapshot. That's really important. That once you grab that snapshot, you can now go to that point in time and you don't have to rely on the replay. So you don't have to worry about if there's a bug or an issue related to the wall. It's another reason to grab the snapshot right away. Once that's out of the way, we can start to look a little closer. So we can do things like trying the PG dump and just seeing if it triggers or if it unearths more problems in the database, so we know what's the state of the world, right? If we don't run into any problems, it is entirely possible that you could get an error message on a block, right? But that could be on here. Well, here's actually something I've seen before, that like I got an error message trying to read a row, but the row had been deleted and my transaction could still see it, right? What that means is when I run a PG dump, it's going to work fine because the PG dump doesn't need that row. Does that make sense? Because my transaction started like 30 minutes ago, so he still needs to see the dead records. But when you run the PG dump is running right now. So it can ignore that row, and the PG dump might just be totally fine. And if you're able to do that, well, you've got your data now, right? It's out. So you can move on with that. One of the more common types of corruption is index corruptions. Index corruptions, right? The great thing about index corruptions is that indexes are a secondary data structure. So the thing with index corruptions is that you can always drop and rebuild the index as long as there's no issues in the table. This is something that we see pretty frequently. In fact, I was just looking at tickets this week where this has happened. Page corruption. So page corruption. Now we're talking about once we get down into the tables, and the one useful thing, and this is also something I've used before in the past, is that there is this is called a developer option. This is not something that customers can set in RDS Postgres, but there is an option to the database called 0 damaged pages. And what you can do with Postgres is you can shut down the database, set this option, and then start the database up. Actually, I don't think you even need to shut it down. I just learned that recently. I think you can actually set it, you might be able to set that right in a session. Once you turn this flag on, if Postgres tries to read a page that has like a checksum failure or is damaged in some other way, what Postgres can actually do is just zero that page out as like an empty page. And what that can enable, and this note is very important, you could lose data if you do that with a table, right? So if you do a table, the thing is like, so if you do it with an index, that doesn't necessarily, you're going to have to rebuild the index because you're now missing like links, right? Between, like, if that was like a leaf node, now you've lost links to a whole bunch of, if that was a branching node, you've lost links to a bunch of your leaf nodes. But like in a heap structure, in a table, it's just the blocks aren't interconnected. So you can zero a block out, and it just means that whatever rows were in that block are lost. But the rest of the table is now fine, and now you don't have the error anymore. So that's an option that can be used to get out of trouble. Yeah, I once used that specifically with a customer who had some issues with some damaged pages, and we were in the end able to pull out everything we could. There were just a handful of pages. We had them validate the data, and it turned out that they didn't lose any important data from their table at all. This is an example of what that might look like, right? So here you see that we did a select count star, and the select count star worked fine, but then when we did a select star, it failed. So the count star, I didn't set this test up, but what it looks to me like is that that's probably using an index, right? And that's why you don't get an error there, but when you do the select star, that actually has to go down and read the blocks of the table, because now we're asking for all the columns, not just the columns in the index. So the error message will look something like this. See how it's telling you the block number, and it's telling you the relation number, the relation path. So this is actually a path to a file name. And we haven't dug into this a ton, but there's two numbers in here. The first number identifies which database you're in. Remember how in Postgres you can have multiple databases. And the second number is, Scott demonstrated this during our lab session the other day when he showed how that was the OID, not the OID, the file node, which starts out as the OID, but he was showing how when you do a table write, the file node will change, but the OID always stays the same. So that's what that is. It's just a number that identifies the name of the file where the data is stored. Here's an example of recovering that page corruption. We set the 0 damaged pages on. It is session settable. I was right about that. And then you just run the select statement again, and you see what happens in the log message is it tells you that I hit an error, and I'm zeroing out the page. Okay? After you've done that, the next thing that we'll do is make a new copy of the table, and we'll copy the data out. And this is where, now, in this case, we don't need to use the PG dump. We're just doing a create table as select, which is also fine because we're not planning to move to a new database. We just want to get rid of this one file. That is always a good policy to do. Like if you've had corruptions in a table, it's a very good idea to just kind of start clean, like get a new clean table set up, move the data into that clean new table, and then just delete the old stuff. Just a good hygiene kind of thing here. All right, transaction log corruption. What does that look like? Here's a couple of different error messages that will indicate to you that you're seeing transaction log corruption. Here's an example where we reset the transaction log, and then we start up the database. And let's see what happens there. Oh, no, I'm sorry. That's an example of trying to, how you can fix the transaction log corruption. So the reason for that is that will, the PG reset xlog-f, I need to double check the man page on that that's doing what I think it is before I say it. I'll circle back to that in a minute. Okay, I'm going to skip over these lab exercises for now, and we'll get into our second section tied into that, which is a debugging section. All right, tools that you have for debugging Postgres and for starting to dig. Job number one is don't lose your data. I was emphasizing that, and we'll start there. Once you're out of pain, then you can start thinking about trying to figure out what was going on, right? Finding your root cause. So at that point in time, so we've recovered our database, it's back up and running. The other thing would be, you've cut your new backup, right? As soon as you're up, you cut another backup. These are kind of basic 101 kind of database management things. And at this point in time, we can now start trying to do some debugging and see if we can figure out what's going on. So some of the tools that we've got in Postgres. First of all, Postgres has an insane amount of logging that it can do. And this is session settable. So you've got the basic logging parameters. They work kind of like Unix logging, where you have there's 7 different logging levels. What we're going to do here is set it down to debug 5, and then take a look at the amount of this is how much log data you start getting dumped out when you set the debug level down. So you can see it's dumping a ton of data out. So that's level 1. The way that you do logging in Postgres is you're going to look at this parameter here that says log min messages. There's also a log client min messages. The word client is in it, and that'll control how many messages are actually coming out to your terminal that you're seeing. So that's a useful one to watch for as well. Then we have some debug messages, which are shown at the bottom. And okay, this is still showing some of the verbose logging that you can get. This is showing a plan, and you can see the level of detail that you can get out of that. Right. And we don't have an example of the other ones that I was hoping for. Single user mode. Single user mode is a special startup mode for a Postgres database. This is something you would use on EC2 or self-managed. In the RDS ecosystem and in the Aurora ecosystem, this is something that the service team would use in a crisis, right? But it's not something that is exposed to customers. But it's important, right? So the single user mode is actually I think some other databases have similar concepts. It's where it starts the database up in a special mode where no other connections are allowed, which gives you the ability to do some important administrative operations that you wouldn't otherwise do. You can use it to repair damage to system catalogs. It is not pSQL. The thing that I always remember this for, single user mode, is also what you have to do if you get into a wraparound situation. So we've talked about transaction ID wraparound a few times, and it's that 32-bit identifier. If you run out of transaction IDs, you get up to 2 billion, and you hit that point. Then what you generally have to do at that point is somebody has to go attach in single user mode and run a vacuum, because the database will stop running. It has to stop to avoid corrupting the data. Where do I go? Okay, here we are. Here's an example of what that would look like. You put the -- single up at the top, and that starts it up in single user mode. And then you can see here that they were looking at, well, this is just a query on the catalog view. because this is, in this case, this is how you would address problems with the catalogs, the global catalogs. Some of the catalog views are interesting too, because they are, so remember I showed you the path name, I highlighted that a few slides back to the table, and it had the database directory and then it had a number for identifying the object. There is a special database directory just for the global catalogs and metadata. So you have there's just a couple of these, but there are things like your PG database, that's a global view, your users and your roles, your security privileges for like at a user level. Much of that is global level things, so those are stored in a special area on your disk. And again, so any issues that you ran into in the catalog, you would use single user mode to address them. Stack traces, probably familiar with these. This is, I won't stay here for long because this is just kind of stuff that we've probably all seen before. Here they're using so you got like pstack is one tool that can do it. GDB is a tool, you can do BT for backtrace inside of GDB. You know what they don't mention in here? My favorite tool for getting stack traces is perf, by far. In fact, they didn't have perf on the slides in here, but perf can do a lot. It can really do a lot. It can do profiling. It can do this, so you can kind of gather stack traces. The other really cool thing that perf does that I haven't seen many people use it, but it's super useful, is that you can put custom probes. You can insert custom probes on any function in your binary, and then every time that probe gets crossed, it can emit a log message. So basically, you can put trace points in. It's not as like sophisticated as dtrace is, although they're actually continually enhancing. BPF is kind of the new thing, but that's closely related to perf. So read about perf sometime. It's a great tool. And it can also do things like this, get a stack trace. I've read so many of these. The Postgres stack traces I think are fairly readable. Let me just walk through this real quick. So what's this guy doing? So if we look at the stack trace, we'll see there's the Postgres main is the main loop. Portal run. A portal is, think of that a little bit like a connection or a session inside of the database. Or connected with a statement, all right? And in this case, we're running a select statement is what we're doing here. So then in order to run it, we do the execute. So remember, we talked about phases of processing SQL. There was the parsing, the planning, the rules engine, the executing it. And this tells us we're in the execution phase right there. And then as we go up now, you'll see these things to talk about nodes, like this exec proc node. A node means like one element of the execution plan. And then underneath that, it tells you what kind of node it is. It's a scan, so we're running a scan. And then execute a projection. Project is a projection means choosing which columns I need to get back. There's a function, and then there's a PG sleep. So this says run a function, and that's what the function actually is. So it looks like this is doing a select PG sleep. Let's go back and see what they did. Select PG sleep 1 from generate series. That's the query, 2626, and that's what it ended up looking like right there. Last but not least, core dumps. Core dumps are turned off by default. That's also true in RDS Postgres. We're not filling up the disk with core dumps all the time by default. However, they are very useful and very important when you have a problem that you're trying to find, and especially if like you know that you're going to be able to generate a crash, right? Like flip on core dumps, generate the crash, you'll get the dump. You can load up a core dump with GDB. Do we have a, we built an example function. All right, then they run the function. So this is kind of neat. They built a function that they're actually loading into the database. This PG function info means it's a Postgres function. And then, so it's called force dump core. They loaded it so they could just run it with a SQL query. So now I just do a select force core dump. And what happens is this is all the error messages you get when a core dump happens, actually. And this is another thing that I've certainly seen before in the world of RDS. This server closed the connection unexpectedly. As an example of that, there was maybe like 7 months ago, sometime last year, I remember, there was a bug in PG hint plan. And I read the description. I was never able to actually reproduce the bug, but somebody was, because they fixed it. And I read the description of the fix. But it had something, you had to get like some very specific combination of prepared statements and bind variables and the right executions. And you could get into a thing where PG hint plan tried to dereference a null pointer, basically, and seg faulted. So this is exactly what you would see. Because what would happen is it's trying to process a query. In the process of doing the planning or the execution, whichever one it was, it calls the code for PG hint plan, and PG hint plan would get this segmentation fault, and the whole thing crashes at that point. It's not able to recover. And so this is what I saw until the patch came in and the patch was deployed across the fleet. We saw something like this. Things to watch for, so you know what you're looking at. It tells you the other thing to be aware of is that in Postgres, in Aurora Postgres in particular, there are many, many situations where if your backend crashes, it will cause the whole Postgres system to restart. The reason for that is that it all depends where the crash happens. If the process crashes in a section of code that has been designated as what is called a critical section, which is a good bit of the code, and it, for some reason, crashes, I feel like they like to happen in the critical places. I don't know, Murphy's Law or something. If it's in a critical section, what that means is that we can't guarantee the state of memory after the crash happens. And so in the absence of having any way to really make sure that there isn't like a memory corruption, the safest thing to do in that circumstance is just to just restart the Postgres processes. It goes very quick. It's just shut down startup of the processes. Grant talked about in Aurora, you have survivable buffer cache, so we don't even lose our cache. It's all still there in memory. It really is just a quick process bounce, but you'll notice it when it happens because everybody will have to reconnect. Pulling it into GDB, just like I was saying, if you're not familiar with this, it's pretty cool, like how capable or just how powerful these tools are. And I guess one other thing that I would point out too is don't think that just because you're on RDS, this stuff is irrelevant to you, because it's not at all. Like the PG hint plan bug that I was just talking about, that was a bug in PG hint plan. I think that it can be very useful for any customer who's running on RDS. I think it's very useful to have a playground in EC2. Have a sandbox environment, have some Postgres code on EC2 box that you can really go poke around at, where you can do things like this. You can attach a debugger, you can do perf. It doesn't have to be your production system, but it's really good to have a sandbox and reproduce things. RDS Postgres is, with the exception of kind of some security-oriented things, the only changes are the bare minimum that is required for us to run it as a service. Other than that, it is just the community Postgres code. All right, and then we had a lab exercise at the end. So that's my corruption deck there, which is talking about community Postgres. But now let's come back and talk a little bit more about specifically in RDS. So I want to highlight now, I'm going to come back and just reiterate a couple of the important strategies. A little bit of this is stuff that I said a moment ago. It's a guy named Paul Valley. He runs a company called Pythian. They're based out of Ottawa, up in Canada. And Paul read a book called The Checklist Manifesto. And he was that book is about the importance of checklists in disciplines where like reliability and safety is really important. And the author of that book, of the Checklist Manifesto, like talks about aerospace industry. He looks at construction. He looks at a whole bunch of places and just talks about the importance of checklists, right? Paul got really inspired, and Paul runs a managed services company that does an awful lot of database administration. And so what Paul did, running that company, was he decided he wanted to come up with a checklist for his DBAs. And he came up with Fit Acer. And I've just been a fan of this ever since I first heard about it. And this just reinforces what I've been saying, that like if you get into a crisis, when you see a corruption or you have an outage, first thing you do is you slow down and you focus. And then you can, I like this checklist. It kind of walks through the things that you should do, having the second pair of eyes look over your shoulder before you press the enter key on any really critical command. This is something that I do as a regular practice. And I don't think that there's any level I'll ever get to where I would not want. If anything, like just the longer that I'm in the industry, the more that I realize how essential it is to have that second pair of eyes look over my shoulder, no matter how confident I am that I'm about to do the right thing. If it's, when you're in a high pressure situation, it's always good, just, hey, I'm about to hit enter. I mean, not necessarily, you don't have to do it when you're typing ls, right? I mean, the point is like, okay, I'm about to like copy the files. I'm about to shut down the database. I'm about to start up the database, there's kind of a, and I've even done this too, like, if I'm working from home, or if it's, it could be the weekend and I got paged, like, usually there's a chime bridge, a bridge that's open. So I'm still, able to do that sort of thing. And we'll even do screen shares. Like if there's another one of the on-call people, we'll set up a screen share so that somebody can just kind of like see and I'll just put my stuff right on the screen share, just, do my work right there so that, one or two other engineers are able to, when they're looking, they can look. And then I can just kind of shout out on the bridge line if I'm about to do something important. Just, hey, somebody take a quick look. I got, just sanity check this for me. I'm it's not doing this at the wrong time or anything like that. So this is where I want to circle back real quickly and talk about the importance of the tactical importance of knowing the RDS architecture. So the real value of understanding all those tools in your tool belt is that you can start to figure a lot of things out about failures that you see. As an example, let's just walk through some scenarios. Well, actually, let me just start at the top. So this is, I kind of wrote this out like a simple flow chart, top to bottom, of sort of steps to take. Very, very first thing you should do is just save everything, right? It's even I have to remind myself, like, okay, cut and paste the error message I just saw and just get it in the ticket. Like put everything in the ticket or put everything in a text file. Put everything somewhere. You want to always kind of save that output, all the important outputs, the important commands, don't lose them. Log files, take backups, that's part of saving everything. You fire off that snapshot immediately. Another thing that I would say, when I say save everything, you've got to pay attention to retention as well. Sometimes you might want to take a snapshot, manual snapshot of your oldest backup, like the one that's about to roll off, right? It would be a very good idea, probably, to just download all of your Postgres logs, especially the old ones that are about to roll off. There's like nothing more frustrating than working on something for 8 hours and then realizing that 2 hours ago, the log file that I needed just rolled off and it was cleaned up. I mean, it is the most frustrating feeling in the world. So that's why I say the first thing to do here is just save this stuff. Save your output, get your log files, take a snapshot of the backup so it doesn't disappear. The thing that you cannot save in RDS, unfortunately, there's no way to do this, is the wall logs. Like once those roll off, they roll off. So that is one of the reasons that in our happiness hints we say, and I hope everybody does this, set your backup window to the maximum of 35 days. Because it also, there's nothing more frustrating than like, you're wrestling with a corruption and then you look and they've got the backup retention set to like 1 day or something ridiculous like that, which has absolutely happened for production systems. Like I've seen this. 2 and 3 here are kind of closely related, but starting to research the failure, just look at what errors, look at what log messages you see, what are the symptoms. And what I tried to do here was like the second column is sort of like the object, and the third column is the thing that you're doing, right? So you're making copies and screenshots of backup and logs. You're going to look at the errors, the log messages, and the symptoms. And what you want to do is document your findings. And the other thing that is almost always helpful is to start assembling a timeline as soon as possible. So cut and pasting the exact timestamps down to the second or down to like the millisecond or the microsecond, like whatever you have. Cut and paste, don't lose any precision of every like important event that you see. On the backup side, remember you got your 3 types of backups. You've got the point-in-time recovery and the snapshots, which are your 2 regular backups. And then you've got, if you have logical backups going on as well, you want to just take an inventory and know what you've got to work with. Another thing from the backup, so now we're going to start getting into kind of the tactical value with these bottom 2. I've got a corruption, we'll say. I've got like a row in a table that I can't access. One of the things I want to do is figure out a timeline. One of the strategies for that is when you start looking at, pull yesterday's backup and just say, is it corrupted there? If so, you can pull a backup from like 3 hours ago. Was it corrupted there? You can start to get a sense of like when the corruption happened by looking at the backups. When I have seen corruptions that were embedded in the wall stream, they tend to replay without causing any errors. So just rolling forward the logs, like it's not going to stop when it hits the corruption, right? It's just that like, I'll just find out that if I restore to 2 o'clock, it's not corrupt. If I restore to 3 o'clock, it's corrupt. So somewhere between 2 and 3, there's a bad wall record that's actually causing the corruption to happen. That sort of thing can happen. And that's where, so take an inventory there. Last is comparing your environments. And this is where we really get down to some really interesting things that you can figure out. So you've got a MAS setup, all right? Let's say we have a MAS setup, and let's say that we try to read the block, and we've got a checksum mismatch, all right? Well, I'll tell you, one of the things that in database engineering we always do is the first thing we say is it MAS? Okay, is it MAS? Well, I'm just going to go look at the other side of that cluster, and I'm going to look at exactly the same block. And it should be the same corrupt block. Usually is. Every now and then it's not. If it's not, what does that mean? It means that the problem is underneath that layer, not above that layer, right? Because if they're different, then the storage replication technology is keeping everything the same. Like that's what it's doing, unless there's a bug in the replication technology itself. But it means like the bug is not above the replication technology, right? If the replication technology was working correctly and the storage is working correctly, they will be identical. If they're not identical, something is wrong at that layer of the stack. It's either the replication bits or it's the storage. So it's like you can start looking at these things and you can immediately you can do exactly the same thing with a read replica, all right? If I have a read replica, then I just right away, just go see if it's corrupt on the read replica. If it is corrupt on the read replica, what does that tell me? That tells me it must be embedded in the wall stream. Because the wall stream is the only thing, there is no storage replication. The wall stream is the only thing that feeds over to the read replica. So like literally that takes like 5 minutes. And in 5 minutes, I can figure out, is the source of my corruption in the wall stream, or is the source of my corruption down at the storage layer is it in the database or out of the database? Is this a Postgres bug or is this not a Postgres bug? That little piece of information is really valuable as you start thinking about root causing and things like that. So that's why I said here, multi-AZ and replicas in particular, and you can start thinking about where the failure likely originated. So that moves you into the root causing area. But just as one final reminder, because I'll say this again and again. You got to stay focused when you're in these situations. Step one is get out of pain. And I've sat with operators. I've even sat with operators in the service team, and we have to remind each other, like, I know your brain is racing and you're thinking about where's the bug, but okay, step one, just get out of pain first. And not only just get out of pain, but slow down, focus, make sure you're typing in the right terminal window. You don't want to type a command in the wrong window. You move slowly, work with a partner, and first priority is get out of pain. And then after that, we'll start thinking about the root cause. So that was the high-level introduction to corruption. Now, let's get into some specifics. This is where I think it'll start really getting interesting.